All right, so this is going to be a review for probability for grade 12 essential math. And so a couple of things that you need to understand, right? What is probability? So when it comes to probability, it is the likelihood of an event. The likelihood of an event occurring. And I'm just going off the top of my head, so if it's a little rough at times, I apologize. I'm going to go back and forth. And so the likelihood of an event occurring, and so you got to be able to state it, right? State it in the following formats, right? You need to be able to go from fraction, decimal, percentage, and even words. Okay. So in and of itself, it's not required for you to simplify fractions. However, it could be that you're given a scenario in a multiple choice, in a form of multiple choice, and that the answer that is given is simplified. So I will go over that just a little bit as well. So again, if you have a fraction, and let's say it could be 1 over 8, it would be your fraction, 1 over 8 chances of something occurring, and then you got to be careful. If you turn that into a decimal, you could actually, because it's not a money amount, you could just leave it like that, or round it to 2 decimals, then it would be like that, okay? If you want that as a percentage, if you want to state this as a percentage, you go back to what's on your screen, on your calculator, and round to 2 decimals at that point. So that'd be 12.5%. Okay, 12.50 would be fine as well. Words, I would go back to my fraction, right? 1 out of 8. Okay. You can also say 1 out of 8 if it's ever required. Okay. Also, the likelihood of an event occurring, it can never be greater than 100%. You just cannot have a probability that's bigger than 100%. So, for example, if you have a bunch of decimals, right, and one of them is 1.2, right, so example 1.5 cannot be, because that'd be 150%. If you turn that into a percentage, this cannot be, right? That's part of that statement right here. So keep that in mind. They will test you on that sometimes. And probability, if you are wanting to have a formula for it, you basically want the number of favorable outcomes, right? So if it's number of red, like what's the probability of grabbing a red, then you want to find out how many red are there, and the bottom is total outcomes. So how many marbles are there in total? How many students are there in total, right? If whatever the scenario may be. Like if you're rolling an even number with a standard die, right? It'd be 2, 4, 6. So that's 3 even out of how many total? 6, and so forth. So that's, in a nutshell, that's probability. Okay. All right, and so this concept is very basic. You've seen that before. So let's look at some examples here. As I was mentioning this, you also need to know that something happening, right? Event happening, an event not happening, right? They always amount to 100%. So you could also do a pie chart. So example, if there's a probability of rain, right, that is 20%, then probability of it not raining, and we denote that with a bar on top of it, would be 80%, and combined you get your 100%. So that is also very important. That's a critical concept. So I'm going to box that in there to know. Okay. Also, you can make predictions with a probability. So let's make an just a short example here, small example. So let's say you have a spinner, and let's just split it up into 4 sections. And we'll go red, blue, purple, and green. Okay, that's your spinner. What's the probability of, sorry, I'm going to go like this, probability of it landing on green, let's say. That would be 1 out of 4. Okay, this is the probability of green. Landing on green. Okay. That would be A, let's say. But what if it asks you, you can also predict. You can make predictions. If you spin, 400 times, okay, how often will it land on green? Okay. Or predict how often it will land on green. So you gotta go prediction, and this lends itself to a variety of different scenarios. Like for example, on a small scale, if you ask like 50 people and 20 of the 50 decide to vote for a certain candidate, let's say candidate A, and then they ask that you come up with your probability, right? 20 over 50. And then they ask, well, if there's like 5,000 people, how many can you expect to vote for that candidate? You use your probability on the small scale and just multiply it by the larger sample. So you got to go probability times large sample. Okay, that's how you do it. So you would go 1 over 4 times 400. And in this case, if you go 1 divided by 4 times 400, that gives you 100 times. And just make sure you have a whole number if that happens. Okay, so that's that. Let's just expand this problem right here. So if it asks for C, what's the probability of spinner not landing on green? Sorry, this doesn't look like landing, does it? What's the probability of the spinner not landing on green? Okay, so, if you want to use the notation that I use and that a lot of textbooks would use, it's not green. So there are 3 out of 4 of that happening, which would be 0.75 or 75%. And you notice that it happening and it not happening, right? If you added the fractions, you would get 1. If you added the decimals, you would also get 1. If you added the percentages, you would get 100%. So that all adds up. Okay. And then we did a little bit of cards. You don't have to worry about that too much. They will give you what you need if it's a deck of cards. I'll do one question where you got to come up with a probability given a word. So I'll box this off. So probability involving letters in a word, let's say. So you would go, for example, trigonometry. Okay. What would be the probability if you cut these letters up and you put them in a in a bag or something in a box, what's the probability of you grabbing a T? Well, you just got to add up the letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 letters. And out of those, we've got 1 and 2, right? 2, a letter T. So that'd be 2 over 12. Here's where I need you to be able to simplify a fraction. You notice that both of them are even. So I would just go ahead and divide it by 2. So that'd be 1 over 6. Just in case they did a multiple choice question, is say the probability of randomly selecting the letter T using the letters that make up the word trigonometry, that'd be obviously 2 over 12 if you did the math, but then simplify would be 1 over 6. They could also give you the answers as a decimal. You just turn that into a decimal and see which one matches your scenario right there. Okay, so if that ever happens, you're prepared for it. Another important concept is to distinguish between a theoretical and experimental probability. Very important. So, how will I do this? Experimental probability. Right? It is based on what actually happened. So you will have some sort of record or some sort of, often a table of what did actually happen. Like I rolled the die and I recorded where it landed on, or I spun a spinner and I recorded where the spinner landed on, or I did a survey and this is what people were saying about their favorite colors and all of that. So that's experimental probability. Theoretical, so if this comes up, they're gonna most likely ask you to distinguish between experimental and theoretical probability. Theoretical probability, it is based on the possible outcomes, okay, not the results of an experiment or trial. Okay. Very important that you notice the distinction between the two. And so I'll give you an example here. The easiest example is, like, let's say you have a table. You have red, green, purple. So technically you only have 3 options, okay, every time. If this is a spinner, there's only 3 options. But you proceed to spin and you get, it lands here 2 times, it lands there 3 times, it lands on purple 5 times, let's say. Okay. The theoretical probability knows that, hey, there are only 3 options and it only landing on purple is just 1 out of 3. Okay, probability of purple. If it asks for theoretical probability, you would say 1 over 3. Experimental probability, you would actually say, well, I spun, how many experiments, how many trials did I do? 10. Okay, so the 10 goes down here. So out of 10 spins, okay, it landed on purple 5 times. So technically, this would be 33.33%, and 5 divided by 2 is 50%, right? So this would be 50% if you converted it. And there's something that I need to say about this. In this scenario, and most scenarios that involve die or dice or coins or a spinner, there is no bias. So we would always go by theoretical probability. And the reason that in this case they're not matching is because your sample is too low. You have to increase this sample, right? Not just 10 times, you have to increase it, then these two should be fairly close, right? They are different. They differ due to small sample. Okay, that's why they are different. So just so you know, they will ask you in different ways. So let's say for example, we just analyzed this and we know what's happening here. But just saying, Johnny says that the probability of the spinner landing on purple is 5/10 or 50%. What kind of probability did Johnny use? And you would have to recognize that and be like, oh, well, Johnny used experimental probability to come up with his answer. If Janine, right, said the probability of purple is 1/3 or 33.33%, what kind of probability did she use? Well, based on this context, you'd have to say theoretical probability, because there's only 1 in 3 chances of it landing on any given color. Okay, so I hope that helps. Let's keep going. Probability continued. The other big concept that I need you to know is dependent versus independent probability. Okay. You know what? Something is telling me I should go back to this and just understand. I'm going to write down, I'm going to squeeze that in, I apologize, but experimental probability is based on trials. Okay, that is the key. And obviously this would also be based on your results, but it's still favorable outcomes over total number of trials. Theoretical probability, it's over the outcomes. I would say possible outcomes. Possible outcomes, okay? Number of trials. So on here, in your little diagram, I'll just, along this line, just say this is trials, and this is based on 3 options. 3 outcomes, or 3 possible outcomes. That's color-coded, right? That's color-coded. So theoretical probability, right? We based it on 3 possible outcomes, whereas experimental probability, we based it on the trials, right? So that's why it's different. I can almost guarantee you that on the exam, they will be different. Okay, they will be different, so that they can check whether or not you understand which one is which. Okay, let's continue. Dependent versus independent probability. Where am I at here time-wise? Sorry, I'm just going to quickly check. 19, okay, gotta hurry up. But dependent, it just means that how should I say this concisely so that it fits nicely? Let me see here. When one event affects another. Right? When one event affects another, for sure. Keywords: not replaced. or without replacement. You should immediately, okay, that should tell you something. Oh, if I did something and I'm not replacing it, then the probability that I'm about to calculate is going to be different from the event that just preceded it. Okay, so that's what you need to know. Independent is when an event, when one event does not affect the other. Okay, keywords, items are replaced. Okay. And obviously you have to be very careful. Sometimes they might come up with an example where it doesn't have to tell you whether it's replaced or not replaced. Like, let's say there's a bag of cookies and a student grabs a cookie from the bag and eats it, okay? If that's the case, obviously they don't have to tell you whether things are replaced or not replaced. It would obviously be a non-replaced item because that person just ate it, okay? So you gotta be able to read carefully. So how's that gonna work? What can you expect in these instances? Well, you can say that, you know, let's do an example here. A bag contains 4 black, 3 white, and 5 red marbles. Okay. State the probability of a student randomly selecting a white marble given that a red one was removed without replacing it. Okay. Removed without replacement. So that should tell you dependent probability. Okay, that right there should tell you this dependent. So how does that change? Well, you used to have, right? You used to have 12 marbles, but you take one has been removed, so now you're down to 11. How do I know it's 12? I added, right? 4 and 3 is 7, and 5 would be 12. And what about, maybe this is a better way to do this is to just say, well, you're removing a red one, so you go here and you cross out the 5 and just turn that into a 4, and you add that up, and now you're down to 11 total. And how many, you want the probability of randomly selecting a white one. There's still 3 white ones there. So that'll be your probability there for that in that particular case. And that's what they're mostly gonna check, okay? They're gonna check for understanding, okay? And just basically, the best way to do this is just go back and remove the one, like change the number of the one that has been removed without being replaced. And then you go for it, okay? This could have been an A, B, C question as well. They could have just said, hey, what's the probability of selecting a white marble, right? It would be at the very beginning, it'd be 3 out of 12. Okay, and then B could be assuming that that is not being returned, right? What's the probability of grabbing another white? well, then you'd be down to 11 because a white one has been removed, and you'd only have 2 white ones left, so it'd be 2 out of 11. So you got to read carefully. Just remember the difference. And next topic would be here, and we have odds, okay? And then we're going to also talk about odds versus odds probabilities and how to go back and forth. So odds, if it says odds in favor of winning, let's say. If it says odds in favor means whatever event follows it, it means that winning will be here, and on the other side you'll have the not winning or losing. Okay. Oftentimes I go just W and W not. Okay. If it says odds against winning, if it says against, that means that the win will be here and not winning will be on the left side. That's what it means. It tells you the order and focus on the event, right? If it says against, then the event is on the right side. If it's in favor, the event is on the left side, okay? And the event being, right, this part right here. If it's against winning, winning is there. If it's in favor of winning, winning is there. Okay? So that's what you need to know. So this would be not win and win. I'm just going to keep it at W. And so it also goes to say that if you have the odds and they ask you what are the odds against this event, then you just flip it and then you get it, right? So just flip it back and forth. So example, odds of, I have to come up with an example. Odds of snow on exam day. Let's say they are 2 to 7, let's say. Odds against would simply be 7 to 2. So, on exam. Okay, 7 to 2, 2 to 7. So that's as simple as that. And let's transition. So what I need you to know when you see snots as odds of, it's in favor. So this means snow, and this means not snow. That's very important. If it's odds against snow, right? Snow is there, and not snow is there. It's very important to be able to read and then match the event or the event not happening with the appropriate number. That is very important. So this is where I will switch over to probability. So what is the probability of snow on exam day? So again, probability is total, okay, 2 plus 7. So you consider the event happening and not happening. That's your total possible outcomes. And we know that snow, probability of snow is 2. That's the favorable outcomes. So that'd be 2 over 9 would be this particular one. Probability against snow. Well, you choose, but what will happen for sure is you add up these two. It doesn't matter which one of the odds you pick. It is 2 plus 7 for sure. And we know that the 7 represents the events where when it's not going to be snowing. So in this case, it's 7 over 9. Okay. And notice that the probability of it happening and it not happening adds up to, in this case, 1. It'd be 9 over 9, which is 1. Okay, so that is something important to keep in mind. I'll give you some examples in a bit. And how do you go from, we're going to go, I'm going to give you examples to go from odds to probability. Okay. I will just say if you have 2 to 7, let's use different numbers. 1 to 5. You do have 1 to 5 like that, and probability will be 1 over 1 plus 5, 1 over 6. In general, you have to know what these numbers represent. Sometimes you might have to use the 5, sometimes you might have to use the 1 up there. But what is for sure is you're going to have to add up these two to get your denominator. If you go from probability to odds, if you go from probability to odds, let's grab a different number. So let's say the probability of the Bombers winning our next Grey Cup is 4 out of 10. Okay, and you're asked to turn this into odds, the odds of winning. You take 4, right? You put that down, and on the other side, it's 10 minus 4. So it's 4 to 6. Okay, don't forget this, because these two always add up to your total, which is that, right? So you always be able to check, okay, this makes sense because if I go back to the probability, there's the 10 underneath there. Let's do a probability, like what if they told you that the probability of the Bombers winning is 65%. How would you turn that into odds? Well, I would say turn this into a fraction. Every time you have percent, it's really over 100. And now you're back to this scenario, right? So you can go 65 to 100 minus 65. It'll be 65 to 35. Okay. By the way, if you have 5s on both, you can easily divide both of them by 5. Okay, and this would be 13, and this would be 7. So reduced, right? So it could be that if it's a multiple choice, it's like which one is would be the odds if there's the odds of the Bombers winning the Grey Cup. If the probability of them winning is 65%, they may give you an option that's reduced. So when you do the math, you might get this and not find it, while you might have to reduce it, okay, to figure it out. You could also reduce your probability right away and then turn it into odds. It's up to you. What else could be thrown your way? Let's do one that actually was done on an exam. So probability of a tadpole surviving is 90%. Okay, that's a probability. State the odds, watch this, against surviving. Okay. First of all, if it's odds, you know that it's going to have the 2 dots. Okay. And let's read first. State the odds against surviving. This tells you where to place the numbers. If it's odds against an event, the event, so surviving, will go here, and this will be not surviving. Okay? So let's turn that into a fraction, 90 over 100. That's much better. So if it says the probability of it surviving is 90 over 100, that means that 90 goes here, surviving. Okay, that's what the 90 represents. And over here, you go 100 minus 90. So it'd be 10 to 90 like this. And if it is if they're ending in 0, you can divide both of them by 10. Okay, and you get 1 to 9. These are the odds against surviving, and that was actually one of the options on the exam. Okay, if you want to quickly read this and just see what 1 to 9 would have been the odds against. 9 to 1 would be the odds in favor. Okay, so you have to be careful there. Another one from an old exam. I'm going to cross this out here. Okay. State the probability of a player, a baseball player, but doesn't matter, we can just summarize it, hitting a ball if the odds are 1 to 4. Okay, state the probability given that the odds are 1 to 4. The odds of that player hitting is 1 to 4. So that means this is hitting, this is not hitting. So obviously you want to take the 1 and put it on top, right? But before you do anything, 1 plus 4, right? Place that underneath, and then the 1, which represents the number of hits, be on top. So 1 over 5 would be your answer in that case. All right. I think we're ready to move on to the last piece, which is expected value. Okay. So let's talk about expected value. And I'm going to give you a formula here, and you got to make sure you have this written down. So expected value, if your answer is positive, play. If the answer is negative, don't play. And every time you calculate, you're calculating it from the player's perspective. As a host, you would say don't host. You should play as a player, but don't host if you're hosting. And in this case, if it's not play, you would want to host. And so vice versa. So you got to be careful there. So the formula is probability of winning the first prize. That's going to be a fraction, right? Times the prize minus cost. Okay? And you will continue this for as many ways as there are to win. Minus, I'm going to steal some space here, a probability of losing. There's always going to be a probability that you lose if it's a game of chance. Okay? Times the cost. So that's very important that you understand that there's always going to be a losing. And the best way is once you have your probability of winning, then you should subtract them from the total, and then you get your probability of losing. So here's an example, okay? I'm going to let you read this first. This is the question from January 2016. Read it. I'm going to pause this here. Give this a try as well. Okay, I'm just going to say that I'm going to summarize this big time. There is a 7% chance so they're sending mail through the mail, they're sending small sample of cereals, and there's a 7% chance that I'm just going to say of a customer buying a box worth $6. Okay. Calculate the samples. Samples cost 40 cents each. So the company, that's basically what it costs to play, because it's a bit of a gamble, right? When you send out samples, you don't know who's gonna take it or not. So in this case, the company is the player here. Okay, they're every time they send out a sample, they're playing the game that costs them 40 cents. And we want to know if this is actually sustainable. Does it make sense for them to do it? So let's go ahead. Expected value, 7%. That's a probability of winning the first prize. By the way, there is only one way to win here, which is the $6. It doesn't mention anything about getting, buying a box that is like $4 maybe. That would be your second prize, but it doesn't give us much else, just this. So this is 7 over 100. Okay, 7% chance of winning. I get $6, but they spend 40 cents to get it out to them. Minus, what's the probability of losing here? If it's 7 out of 100 that you're gonna win, then you gotta go 100 minus 7. That's 93, right? 93 out of 100 chance that you're not gonna win. And you're just gonna lose that amount 93% of the time. Okay. So this turns out to be 0.07. This turns out to be 560 minus this would be 0.93. Don't round these. Use the whole thing. Okay. And if you calculate this, you get 0.392 minus 0.93 times 0.4. That's 0.372. If you subtract them, you get 0.02. It's not negative, sorry. I should have been careful there. 0.02. And make sure you have a dollar sign and 2 decimals. Okay? Dollar and 2 decimals. And then in this case, it asks to justify, right? It says this: justify whether the company should try this form of advertising based on your answer in part A. If you got a negative answer, you would obviously say no. Yes. Continue to send samples since EV, expected value, is positive. You got to make sure you make reference to that, okay? Which means gain, right? Which indicates gain for the company that's playing this, okay? All right. I think this is it for probability. I may have forgotten something, but I think in essence you have quite a bit here.